In this slide, we focus on security and DevOps, and specifically highlight some quick wins that can be achieved to bolster security. These quick wins are practical and can provide immediate enhancements to your DevOps practices. First, implement automated security testing in your CI/CD pipeline. By integrating security checks early, you can catch vulnerabilities before they make it into production. Second, focus on using secure coding practices. Educate your team on the latest secure coding guidelines and ensure they are followed. Third, employ least privilege access controls. Granting minimal required access to users and services reduces the risk of unauthorized access. Additionally, ensure continuous monitoring and logging. Maintain visibility into system activities and analyze logs regularly to detect and respond to security incidents promptly. Another quick win is using up-to-date dependencies. Ensure third-party libraries and dependencies are always current to avoid known vulnerabilities. By applying these immediate strategies, you can significantly increase your security posture in a DevOps environment with minimal disruption. The journey towards comprehensive security is ongoing, but these steps can provide a strong foundation. In this section, we'll delve into application security testing, AST. Understanding AST is crucial for maintaining robust security within your applications. First, what is AST? Application security testing involves using various tools and methodologies to identify security vulnerabilities within your applications. There are different types of AST tools, each serving a unique purpose. Static application security testing, SAS, analyzes source code to detect vulnerabilities early in the development process. Dynamic application security testing, DAST, examines your running applications to find security flaws from an external perspective. Interactive application security testing combines aspects of both SAST and DAST by examining applications in real time during execution. Software composition analysis focuses on identifying vulnerabilities in third-party and open-source components within your software. Why is AST so important? Early identification of vulnerabilities can significantly reduce the cost and effort required to fix them. Additionally, integrating AST into your continuous integration, continuous delivery, CI/CD pipelines ensures that security is continuously enforced throughout the development lifecycle. We will explore various popular AST tools in further detail, which will aid you in making informed decisions about which tools best suit your security needs. Now that we have an understanding of what application security testing AST is and its importance, let's dive into some of the popular tools used in the field. For static application security testing, SAST, we have SonarQube and Checkmarks. These tools analyze source code to identify security vulnerabilities early in the development process. When it comes to dynamic application security testing, DAST, OWASP, and Burp Suite are among the most widely used. These tools test your application in its running state to find vulnerabilities such as SQL injection and cross-site scripting. For interactive application security testing, IAST, Contrast Security, and Seeker are popular choices. They combine the strengths of SAST and DAST to identify vulnerabilities in real time as you interact with your application. Lastly, in the category of software composition analysis, SCA, tools like Black Duck and Snyk are invaluable. They help you identify and mitigate risks associated with third-party libraries and dependencies. These tools play a crucial role in building secure applications by identifying potential security issues throughout the development lifecycle. When it comes to adopting application security testing, AST, in development, integration into your continuous integration and continuous deployment CI/CD pipeline is crucial. This involves using tools like Jenkins and GitLab CI to automate security testing seamlessly, along with the build and release processes. For instance, with SonarQube, you can initiate a code analysis by running a command such as Sonar Scanner during your build process. This ensures code quality and security are checked continuously. It's essential to follow best practices for AST integration. Automate your security testing to ensure that it's consistently applied across all deployments. Adopting a shift-left security approach, where security checks are performed early and throughout the development stages, helps in identifying and mitigating vulnerabilities sooner. Furthermore, ensure your AST tools are updated regularly to handle the latest security vulnerabilities and improvements. This proactive stance in your development pipeline not only boosts security, but also enhances overall software quality. Let's move on to the process of adopting application security testing, AST, in a production environment. This stage is crucial for maintaining the security and integrity of your applications after they have been deployed. First, let's talk about monitoring and alerting. Real-time monitoring of applications is essential for identifying and addressing security issues as they arise. Tools such as Dynatrace and App Dynamics can provide the necessary insights into application performance and potential vulnerabilities, allowing you to react swiftly to any threats. Next, implementing a robust incident response plan is key. Incident response involves identifying, managing, and mitigating security incidents to minimize their impact. Regular security audits and assessments should be conducted to ensure that your response plan is effective and up to date. By adopting these practices, you will be well prepared to handle any security challenges that may arise in a production environment. In this slide, we will delve into the latest trends in application security for 2024. One key resource that informs these trends is the DBIR, or the Data Breach Investigations Report. According to the DBIR, web applications continue to be the primary attack vectors. Attackers frequently exploit vulnerabilities within web applications, making it crucial for us to focus on securing these areas. Another significant trend is the use of stolen credentials. Attackers often obtain these credentials through various means, such as phishing or breaches, and then use them to gain unauthorized access to systems. It's imperative to implement strong authentication mechanisms and regularly monitor for any signs of credential misuse. Stay tuned as we explore strategies to overcome common security challenges and effectively protect our applications. Security challenges are prevalent in current application development, and addressing these is critical for protecting systems. This slide highlights common issues and strategies to overcome them. Common issues include a lack of security awareness among team members and insufficient security resources. Without a firm understanding of security principles or adequate resources, applications are left vulnerable to attacks. To tackle these issues, a key strategy is to develop security champions within teams. These individuals can advocate for security best practices and elevate the overall security posture of the team. Additionally, implementing continuous security training and education ensures that all team members are up to date with the latest security threats and defense mechanisms. By addressing these common issues and implementing these strategies, teams can significantly enhance the security of their applications and better protect against potential threats. Now let's focus on the concept of security by design. This approach emphasizes the integration of security measures right from the initial design phase of a project. By incorporating security early on, we can proactively identify and mitigate potential security risks before they become significant issues. One practical step in implementing security by design is through threat modeling. This process involves systematically identifying potential threats and vulnerabilities in the system, and it allows us to design appropriate security controls to counter these threats. Another crucial aspect is secure coding practices. This refers to the adherence to coding guidelines and standards that minimize the introduction of security vulnerabilities during the development process. By training developers on secure coding techniques, we can significantly reduce the risk of common issues such as injection attacks and buffer overflows. By adopting these practices, we ensure that security is not an afterthought, but a foundational element of our design and development process. This proactive approach not only enhances the security posture of our projects, but also saves time and resources in the long run by preventing security issues rather than responding to them reactively. A pivotal component in enhancing the security posture of any development team is the concept of developing security champions. Security champions serve as advocates for security within their respective teams, bridging the gap between security experts and developers. They ensure that security is treated as a priority throughout the development lifecycle. Training and empowerment of these champions are crucial. By conducting regular workshops and training sessions, teams can stay up to date with the latest security practices and emerging threats. Additionally, providing them with the right tools and resources enables security champions to effectively implement and promote secure coding practices within their teams. Through these measures, security champions become instrumental in fostering a culture of security, ensuring that it's integrated seamlessly from the design phase and throughout the development process. On this slide, we'll be diving into a more advanced approach to security within the development lifecycle, moving beyond merely identifying vulnerabilities. First, we have contextual security. This involves understanding not just the technical aspects, but the business impact of vulnerabilities. It's crucial to grasp how each vulnerability could affect the organization's operations and assets, allowing for more informed decision-making. Next, we focus on a risk-based approach. Instead of treating all vulnerabilities with equal urgency, this approach advocates for prioritizing them based on the risk they pose. This means assessing the potential damage and likelihood of exploitation to address the most critical issues first. Finally, we look at example tools. There are various risk assessment frameworks and tools available that can help in this process. These tools provide a structured way to evaluate and prioritize risks, enhancing your ability to protect critical assets effectively. Understanding these elements allows security champions to advocate more effectively for security measures that align with both technical requirements and business priorities. Let's delve into integrated security program management and what makes it effective. Key elements of an integrated security program include comprehensive security policies that cover all organizational aspects. These policies create the foundation for a consistent and thorough approach to security. Another vital component is cross-functional collaboration. Security cannot operate in a silo. It requires the involvement of various departments working together to identify and mitigate risks effectively. For those looking to develop or enhance their security programs, there are established frameworks available. The NIST Cybersecurity Framework provides a robust, flexible framework tailored for managing cybersecurity risk. Another global standard is ISO/IEC 27001, which outlines specifications for establishing, implementing, maintaining, and continually improving an information security management system. Utilizing these frameworks can help standardize practices, improve security posture, and ensure compliance with regulatory requirements. Empowering developers to build secure applications involves several critical strategies and resources that can help enhance the security posture of your software right from the developmental phase. First, providing clear security guidelines is essential. Developers need concise, actionable advice and standards to follow throughout the coding process to ensure they are creating secure applications. Next, integrating security tools directly into development workflows can greatly assist. Tools that perform real-time code scanning, identify vulnerabilities, and enforce security policies will help developers catch and fix issues early, reducing potential risks. In terms of resources, online tutorials and comprehensive documentation can be invaluable. These resources enable developers to understand security principles and practices at their own pace and according to their specific needs. Additionally, community support provides a collaborative platform where developers can share knowledge, ask questions, and solve problems together, fostering a culture of continuous learning and improvement in security. Lastly, utilizing advanced tools like GitHub Copilot for secure code review can offer developers intelligent suggestions and potentially identify security flaws early in the coding process. This AI-driven approach ensures that the code being developed adheres to security best practices, enhancing the overall quality and security of the final product. By leveraging these strategies and resources, developers can play a pivotal role in the creation of secure applications, effectively bridging the gap between development and robust security practices. In conclusion, integrating security into the DevOps lifecycle is crucial to building secure applications. By embedding security practices early and continuously throughout the development process, we can significantly reduce vulnerabilities and enhance overall application security. Remember, continuous improvement and adaptation are key. Security is not a one-time effort, but an ongoing commitment. Now let's move on to our next topic. Let's now dive into the questions and answers segment to clarify some key concepts. The first question we have is, what is the main difference between SAST and DAST? SAST, or Static Application Security Testing, analyzes your source code for vulnerabilities without actually executing the program. It's a static analysis method aimed at identifying potential security flaws in the application's codebase. On the other hand, DAST, or Dynamic Application Security Testing, approaches security from another angle. DAST tests the running application for vulnerabilities, meaning it examines the application in its operational state to find security issues that might not be apparent in the static code. By understanding these distinctions, you can more effectively decide when and how to employ each type of testing in your security practices. Q2, how can you integrate AST Tools into a CI/CD pipeline? A2, to integrate application security testing, AST Tools, into a continuous integration, continuous deployment, CI/CD pipeline, you can utilize plugins and automation scripts. These plugins and scripts enable you to run security tests automatically as part of the build and deployment process. By embedding these security checks into the pipeline, you ensure that vulnerabilities are detected early and consistently, allowing for quicker remediation and maintaining the security integrity of your application throughout its lifecycle. Q3. What are some common challenges when adopting AST in production? A3. There are several challenges that organizations face when integrating application security testing AST into production environments. Firstly, ensuring real-time monitoring can be difficult, but is crucial to catch vulnerabilities as they appear. Another major challenge is handling false positives, which can consume time and resources if not managed properly. Lastly, maintaining performance is essential, as running security scans can sometimes slow down the deployment pipeline. Overcoming these challenges requires careful planning and the use of advanced tools tailored for performance and accuracy. Q4. Why is it important to develop security champions within development teams? A4. Developing security champions within development teams is crucial for several reasons. Firstly, security champions help promote security best practices. They are able to influence their peers and integrate security considerations right from the start of the development process. This proactive approach helps in identifying and mitigating security issues early on, reducing the risk of vulnerabilities. Furthermore, security champions act as a bridge between security and development teams. They facilitate better communication and collaboration, ensuring that security directives are clearly understood and properly implemented. By having dedicated members within the development team who are well-versed in security, organizations can foster a culture of security awareness and accountability, leading to more secure software development overall. Q5. What is a risk-based approach to vulnerability management? A5. A risk-based approach to vulnerability management involves prioritizing vulnerabilities not just by their severity, but by considering both the potential impact and the likelihood of exploitation. This method ensures that resources are focused on addressing the vulnerabilities that pose the most significant threats to the organization, thereby optimizing the overall security posture. To wrap up, we hope you enjoyed the content presented in this course. If you found it valuable, please leave a like. Your feedback is important to us, so feel free to comment below with any questions or observations you might have. Don't forget to subscribe to the channel to stay updated on our latest courses. Sharing this with friends and colleagues can also help spread the knowledge. Thank you for participating.